Good morning to another. This is Dr. Vijay Kumar, working as an assistant professor in the Department of Mechanical Engineering from St. Peter's Engineering College, Hyderabad. Today I am going to discuss about the steam turbines topic. It is from the Unit 3 from Thermal Engineering 2 subject. Actually, steam turbines is the major component in the steam power plant layout. The function of the steam turbine is here the heat energy, whatever the heat energy developed in the boiler is further converted into mechanical energy, and the mechanical energy is converted into electrical energy to generator. Here, the steam turbine is a mechanical device that extracts thermal energy from pressurized steel and transforms it into mechanical work. Because the turbine generates rotary motion, it is particularly suited to driving electrical generator. Around about 90% of all electricity generation in and around the world is by use of steam turbines. Actually, a steam turbine is powered by steam. As hot gases, uh, as hot gaseous steam flows past the turbine's spinning blades, steam expands and cools, giving off most of the energy it contains. The steam spins the blades continuously. The blades thus convert most of the steam potential energy into kinetic energy. The turbine is then used to run a generator producing electricity. The basic parts of steam turbines are blades and rotors. A set of blades is known as a stage. They also have steam inlets, which usually a set of nozzles and outlets. Two independent mechanisms known as governors are used to ensure safe operation of the turbine. Here, the way that two basic types of steam turbines are either impulse turbine or reaction turbine. The main differences between the impulse and reaction are there is the impulse, the rotating blades are like deep buckets. Here, high velocity jets of incoming steam from carefully shaped nozzles kick into the blade, pushing them around with a series of impulse, and bouncing up to the other side with a similar pressure but much reduced velocity. Whereas reaction turbine, in a reaction, there is a second set of stationary blades attached to the inside of the turbine case. This help to speed up and direct the steam onto the rotating blades at just the right angle. Before the steam disappears with a reduced temperature and pressure. So here the main advantages of steam turbine over steam engine is the reciprocating motion of the piston is transformed into rotary motion of crankshaft. It requires heavy flywheel and perfect balancing is required due to variation of torque in case of steam engine, whereas steam turbine, the kinetic energy of steam jet is directly utilized to rotate the rotor or wheel. Some of the advantages offered by steam turbines over steam engines are steam turbines having the higher thermal efficiency. Here the no reciprocating parts and hence heavy foundations are not required. Here torque is uniform and does not need any flywheel, whereas no rubbing parts, no internal lubrication is required. Here higher speeds may be developed with greater speed range, and can generate power ranging from few megawatts to 1000 megawatts, can be directly coupled to high-speed machines, and governing is easy compared to steam engine, and it is a less maintenance and require less floor space for given output. And the exhaust steam is free from oil, hence condensate can be reused as feed water. And the main disadvantage of steam turbine over steam engine is here it is not suitable where frequent stopping and starting is necessary. Condenser must be provided to take advantage of greater range of expansion. And next, so while comparing to the gas turbine, when compared to gas, but in case of the compared to gas turbine, if the steam or gas turbine serves as basic prime mover in most of the power plants, and they operate on the same basic principle, but due to difference in the characteristics of gases and steam. The steam turbine, in comparison with the gas turbine, operates with a lower inlet temperature but with a higher inlet pressure. Exhaust pressure of steam in steam turbines in a normally below the atmospheric pressure, whereas in gas turbine it exceeds the atmospheric pressure. Where steam turbine is an external combustion engine, but in case of the gas turbine is an internal combustion engine. For a given same output, the weight of steam turbine is higher than that of gas turbine, where the maintenance of steam turbine is costlier than the that of gas turbine. And efficiency point of view, steam turbines is lower than that of gas turbine. And now let us discuss about the working principle of steam turbines. Here, the steam turbine is essentially a flow machine in which heat energy in the steam is transferred into kinetic energy, and this kinetic energy is utilized to rotate the rotor while steam flows through the turbine. During the flow of steam through the nozzle, the heat energy is converted into kinetic energy with the help of enthalpy drop. The steam with a high velocity enters the turbine blades and suffers a change in the direction of motion, which gives rise to change of momentum and therefore to a force. This constitutes the driving force of the turbine. This force acting on the blades in the circumferential direction setup, the rotation of the wheel or rotor. As the wheel rotates, each one of the blades fixed on the rim of the wheel, comes under the action of the jet of steam, which causes the wheel to rotate continuously. Now next, classification of steam turbines. The main classification of steam turbine may be according to the action of steam, according to the direction of steam flow, or according to the exhaust condition of steam, and or according to initial conditions, or according to number of stages, or according to uh, use, etc. Whereas in case of the according to the action of steam, the further classified into impulse turbine, reaction turbine, or impulse and reaction turbine. And in case of according to the direction of steam flow, either axial flow turbine or radial flow turbine. The main differences between the axial flow turbine and radial flow turbine, here the steam flows in a direction parallel to the axis of turbine in case of the axial flow, whereas radial flow, the steam flows in a direction perpendicular to the axis of the turbine. If in case parallel to the axis of the turbine is the axial flow, in case of perpendicular to the axis is the radial flow turbine. According to the exhaust condition of steam, either condensing turbine, or non-condensing turbine. Here, condensing turbine, the steam at a pressure less than atmosphere is exhausted into the condenser, whereas the non-condensing turbine, pressure of exhaust steam is greater than the atmosphere. Whereas according to initial conditions, the turbine may be low pressure turbine, high pressure turbine, or medium pressure turbine. It depends on the range of the pressure in between. If required 1.2 to 2 bar, we are choosing the low pressure turbine, whereas in case of the up to 40 bar is the medium pressure turbines. Above 40 bar are the high pressure turbines. Next classification according to the number of stages. Here the number of stages may be single stage or multi-stage turbines. Next, last according to use, either stationary turbine or non-stationary turbine. Stationary turbines are the power plants and for driving turbo blowers and pumps. Non-stationary turbines used to drive ships and steamers, etc. So next class we'll discuss about the how to construct the combined velocity triangles of the impulse turbine and reaction turbine or single stage turbine or multi-stage turbine. And next further we'll solving the some of the example problems. So thank you, Vananda.